This is the second Intro Linux OS Operations workshop. In the previous workshop, we learned about the following Linux commands. The ls command lists the files and directories in the current directory. It can be used with the -l argument to output in a list format, and with the -a argument to include hidden files and directories in the output. These two arguments can be combined to produce both outputs. The cat command lists the contents of a file. The name of the file to be read must be supplied as an argument to the command. The echo command creates output based on whatever argument is supplied to it. It is very useful for creating output for redirection. Output redirection is the process of redirecting the output of a command, either into a file or into another command. Here, the double greater than symbols redirect output into a file, but if that file already exists, it will instead append to that file. The cd command changes the current directory to the one specified. The new directory must be supplied as an argument to the command. The file command identifies the type of contents for a specified file. The file name must be supplied as an argument to the file command. The find command allows a search of files and/or directories in the file system and matches files in the output according to the criteria provided by the command arguments. The argument -type searches by files or directories, and the argument -size searches for files of a particular size. The pwd command will output the name of the current directory, also known as the present working directory. Open your command line interface terminal, then navigate to the following URL in a web browser. For this workshop, we'll be using Windows 11 as our host machine, but the methods we'll use are nearly identical to how it would be performed using Windows 10. Since most computer users use Windows as their operating system, we'll be using the built-in Windows tools to connect to another computer, the Bandit CTF server, which is using Linux. Similar to the previous workshop, we will first open up a Windows command prompt, CLI. To access the Windows command prompt, we'll go down to the search field at the bottom of the Windows toolbar, then type in CMD. The command prompt app should show up as the best match. Click on that, and the command prompt window will appear. In order to connect to the Bandit CTF server that we'll use to learn Linux, we'll use the SSH program to remotely log in and access it. But first, we have to remind ourselves of what the Bandit CTF Level 6 password is. In the previous workshop, we were recording the passwords for the Bandit CTF, so the banditpass.txt file should still be present. On Windows, we can use the dir command from the command prompt. To read the file, we can use the type command. It should be noted that the passwords for the Bandit CTF levels change every few months, so the passwords you see in this video are probably not valid anymore. We copy the password by highlighting it with the mouse and using the Ctrl-Shift-C keyboard shortcut. We use the same SSH command we used for the previous workshop, but we supply the Bandit 6 username because that's the level where we left off previously. When prompted to enter the password, we paste in the password we copied earlier by using the Ctrl-Shift-V keyboard shortcut. We've successfully logged in. Now let's look at the level objectives on the Bandit CTF webpage. According to the objectives, the file with the password is somewhere on the server and has the following properties. Owned by user Bandit7, owned by group Bandit6, and 33 bytes in size. Since we're looking for files with specific attributes, we should use the find command to locate the file, like we did in the previous level. The find command is used to search for files on the system. It can be used with many different arguments and flags to refine its search parameters. Here's the find command syntax we will use. It's a bit long, but it will return very refined results. Find is the name of the command. The slash is the location to be searched. In Linux, slash by itself indicates the entire file system. Next is the -type F switch, which limits the results to files. Then the -user argument, which filters results to only files owned by user Bandit7. Then the -group argument, which only returns files owned by the Bandit6 group. Next is the -size argument, which restricts output to 33 bytes. The find command uses the suffix C to denote bytes. The last part of the command is a modification to our output to omit error messages by redirecting them to the dev null trash file. This last portion of the command is not unique to the find command and can be used with any command where we expect our output will contain many error messages. We can use the following find command to locate the password file. After we run the command, we see that there is only one file in the system that fits all of our criteria. We can copy the file path for this file using the Ctrl-Shift-C keyboard shortcut. Then read the file with the cat command, pasting in the file path with the Ctrl-Shift-V keyboard shortcut. Just as we did in the previous workshop, at the end of each Bandit CTF level, we copy the password, exit the server, then add the password to our Bandit pass text file using the echo command. That's the end of Bandit level 6. To log in to Bandit 7, we can use the up arrow key on our keyboard to access the command prompt history. So we can modify the SSH command to access Bandit level 7. And paste the password we got from the previous level to log in. Let's take a look at the level's objectives on the webpage. The objectives state that the password can be found in the data.txt file next to the word millionth. The Grep command searches within the contents of files for specified strings. It is very commonly used to pick out specific words or phrases. The syntax for the Grep command we'll be using is as follows. Grep is the name of the command, followed by the string argument, which is the pattern we're searching for. Then last, the name of the file/directory we're searching inside of. First, let's locate the data.txt file with the ls command. The data.txt file is here. But if we use the cat command to read the file, we see that there is way too much data in this file to read it easily. So we'll need to use the grep command to filter out all of the output from this file except for the line that contains the word millionth. When we run the command, we see that the password is located next to the word millionth. To finish out the level, we copy the password, exit the server, and add the password to our Bandit pass text file. That's the end of Bandit Level 7. We'll access Bandit 8 in the usual manner. Let's take a look at the level's objectives on the webpage. Once again, we're looking through a file named data.txt, and the password is the only line of text that occurs only once in the file. The sort command takes all of the lines contained within a given file and returns them in alphabetical/numerical order. Here is the syntax for the sort command we'll be using. The name of the command is sort, followed by the file or other input that will go through the sort operation. The Uniq command takes all of the lines in a given file and removes any lines with identical contents to the one above it. This command is very useful for removing consecutive blank lines in a given file. And here is the syntax we're going to be using for the Uniq command. Uniq is the name of the command. The -C switch modifies the output to include the number of times each line appears in the file. And the last argument in the command is the file to be processed. In Linux, command piping is the process of passing the output of one command into the input of a second command. This is a very useful feature because it allows commands to be chained together to achieve a lot of flexible output. This is one of the commands we'll be using to solve this level. It includes command piping from the sort command into the Uniq command. This is the first command, sort. This is the input argument for the sort command, the data.txt file. The pipe character instructs the system to use the output of the first command, sort, and use it as the input for the second command. The second command is Uniq, and this switch on the Uniq command will return a count of each line in its output. The file input, which is usually required for the Uniq command, is absent, since it will be piped into the Uniq command from the sort command output. We use ls to list out the directory's contents and see that the data.txt file is here. If we read the file, we see that its contents are lines of alphanumeric strings, any of which could potentially be the flag we're looking for. We can use the sort command to group all of the lines with identical values together. The default use of the sort command sorts all lines of a file alphanumerically. But using the sort command alone won't let us easily see which line only appears once in the file. So we'll be using the output of the sort command as the input of another command using the pipe character. Before we run this command, let's go over what it's going to do. The sort command outputs all of the file content in alphanumeric order. Then the pipe character passes that output as input for the next command, Uniq. By default, the Uniq command omits lines of text that are identical to the value of the previous line. And when run with the -C flag, the output includes a number beside each line, which indicates the number of times the lines appear in the input. We run the command, then scroll up a bit and see that this line of text only occurs once in the file, which means that this is the password to Bandit 9. Before we finish the level, we should learn how to easily read the password if the output of our command were much larger than what's given here. We're going to run this command, and we see that it's made up of 3 commands separated by pipes. which means the output of the sort command is used as the input of the Uniq command, and the output of that Uniq command is used as the input of the second sort command. This allows us to easily see the line in the file which appears only once. So we copy the password, exit the server, and add the password to our Bandit pass text file. That's the end of Bandit Level 8. Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming. We can log in to Bandit 9 in the usual manner. Then we look at the level objectives on the web page. The password for the next level is stored in the data.txt file in one of the few human-readable strings. Preceded by several equals symbols. The mention of few human-readable strings implies that most of the contents of the file are not human-readable. The contents of most computer files can be roughly divided into two types: binary data, which is intended to be read by software, or text strings, which are intended to be read by humans. Files containing binary data will output gibberish when read from the CLI console. The strings command is used to return human-readable text from files. It is often used to find text inside of files that contain both text and binary data. The syntax of the strings command we'll be using is the following. Strings is the name of the command itself, and the operand for the command is data.txt, which is the file from which the text strings will be extracted. The data file is in our current directory. Using the file command, we see that this file contains mostly data, not text. We can confirm this with the cat command, which shows that we can't read much of this file's contents. However, most data files also contain human-readable text, which are also referred to as strings. If we run the strings command on data.txt, we see that there are a lot of strings, but these strings don't seem to make a lot of sense. That is because a lot of computer data can be unintentionally interpreted as letters, numbers, and symbols. There's a lot of lines of text here, but the level description indicated that the password was preceded by several equal signs. So we can pipe the output of the strings command into the Grep command, providing the pattern we're looking for. Remember, we should wrap the equal signs in quotes, otherwise they might be interpreted as special characters. The output of the command includes the password. So we copy the password, exit the server, and add the password to our Bandit pass text file. That's the end of Bandit Level 9. The last level we'll be covering in this workshop is Bandit 10, and it can be accessed in the usual manner. Now let's look at the level objectives on the web page. The password is contained in the data.txt file. which contains Base64 encoded data. The Base64 command encodes/decodes data according to the Base64 codec. It is often used to convert data for transmission across computer networks. The characters used in Base64 encoding are shown here. Note that all Base64 encoded strings must consist of a number of characters that is divisible by 4. In cases where an encoded string is not divisible by 4, the encoding process will pad out the string with equal symbols until the string is divisible by 4. The syntax of the Base64 command we'll be using is the following. Base64 is the name of the command itself. The -D switch enables the decode function of the command. And the last part of the command is the name of the file containing the Base64 encoded string. If we try reading the file, we don't get any relevant data. This is because the data has been encoded using the Base64 codec. To decode a file, we use the Base64 command with the -D switch to indicate a decode operation, followed by the file name containing the Base64 encoded data. The output of the command contains the password for the next level. So we copy the password, exit the server, and add the password to our Bandit pass text file. That's the end of Bandit level 10. Let's take a few minutes to review the different Linux commands we covered in this workshop. The find command is used to search for files on the system. It can be used with many different arguments and flags to refine the search parameters. The Grep command searches within the contents of files for specified strings. It is very commonly used to pick out specific words or phrases. The sort command takes all of the lines contained within a given file and returns them in alphabetical/numerical order. The Uniq command takes all the lines in a file and removes any lines with identical contents to the one above it. This command is very useful for removing consecutive blank lines in a given file. Command piping is the process of passing the output of one command into the input of a second command. The strings command is used to return human-readable text from files. It is often used to find text inside of files that contain both text and binary data. The Base64 command encodes/decodes data according to the Base64 codec format. It is often used to convert data for transmission across computer networks. In the next HackerFrogs AfterSchool Linux OS workshop, we'll switch gears and improve our Linux understanding with the TryHackMe educational platform. Looking for more study material on this workshop's topics? See this video's description for links to supplemental documents and exercises. Until next time, HackerFrogs!